Hello, my name's Owen. I'm a tutor here at Breakthrough Maths, and today I'm going to be going through three areas of algebra I think you should focus on for your junior cert. These include terms and expressions. This is also called what? Linear equations. Just solving for x, it's fine. Second thing is solving quadratic equations, so getting two values for x or one value of x from a quadratic. And the third thing is going to be factorization, basically just making messy equations look nicer. Let's get into it. All right, first thing. Linear equations. Like it says here, all we want to do here is just put x on one side and get all the other numbers to the other side so we can see what x is. I'm going to do an example. So here we have 3x minus 7 is equal to 4x plus 14. I'm going to write it again here. 3x minus 7 is equal to 4x plus 14. How do we solve this? Well, I would like to get all the x's to one side and all of the other numbers to the other side. So what I'm going to do is I'm first going to minus 3x from both sides. That way, the 3x's here are going to cancel, and I'm going to be left with a 0 minus 7 is equal to 4x minus 3x plus 14. And 4x minus 3x is just going to be 1x plus 14. Now, what am I going to do? Now I'm going to minus 14 from both sides. I'm going to have minus 14 minus 7 is equal to x. So that means x is going to equal minus 21. Boom. Simple as that. I did that in a bit of detail with the minusing from both sides. You can also think of it as we're going to bring the 3x over to the right and we're going to bring the 14 over to the left. Solve everything and find x. Now, here's another example. 8x plus 5 is equal to 3x plus 9. I want you to pause the video now and try this on your own. Or you can mute the mic and watch me do it as you do it. Whatever you like, I'm going to do it now. And hopefully you've tried it yourself. Or if not, you can watch me do it. So 5x or 8x plus, why does it keep doing that? Stop. 8x plus 5 is equal to 3x plus 9. Same thing again here. This time, I'm going to do it like this. I'm going to bring the 3x over here. So I'm going to minus 3x from both sides. And I'm going to bring the 5 over here. Notice I always bring the x to the side with the bigger x. So like in the previous example, what did I bring over? In the previous example, I brought the 3 over to the 4 because the 4 is bigger. Because we always want a positive x value. It just saves us a step at the end. So yeah, I'm going to bring over the 3x. I'm going to bring the 5 over to the right. So I'm going to have 8x minus 3x is equal to 9 minus 5. Now, we can just do 8x minus 3x is going to be 5x. And 9 minus 5 is just going to give us 4. Now, the tricky part here, a lot of students will think you minus 5 from both sides to get rid of that 5. But the 5 and the x here, they're multiplying together. So the only way we can separate them is if we divide both sides by 5. Why does it keep doing that? Divide both sides by 5. That way, we're going to get 5 divided by 5 is just going to be 1x. That's equal to 4 divided by 5. So that's our answer. X is equal to 4 over 5. Boom. And that's all linear equations is. It's literally just solving for x, putting all the x's to one side, all the other numbers to the other, solving for x. Now, here are three other examples. I'm not going to do these out. These are for you to try if you want to get some more practice. Try them out, see if you can get x. And if you need to, you could probably find solutions to these online, or there's probably calculators online that can solve these for you if you're having a bit of trouble. Now, the other part of linear equations would be fractions. And now, fractions would confuse a lot of students. They would think, oh, like what we were doing before might seem quite easy, and now it's a fraction, it's impossible. It's the same damn thing. We just have to include another step. So we're going to have 9x minus 8 divided by 4 is equal to 7. So clearly the fraction here is the problem for most students. So let's just get rid of the fraction. Multiply both sides by 4. That way you have the 4 multiplying over here and you have this 4 dividing over here. So these 4s are going to cancel and you're going to be left with 9x minus 8. And that's equal to 7 times 4, which is 28. Then add 8 to both sides. We want the x on its own. So then we're going to get 9x, the 8s are going to cancel, and we're going to get 28 plus 8 is 36. And then again, remember, the 9 and the x here are multiplying. So the only way we can separate them is if we divide both sides by 9. That way, we're going to get x is equal to 36 divided by 9, which is 4. Boom. And that's our answer. X is 4. Same thing, just have to deal with the fraction. Now, I want you to try this on your own. It may look a bit tricky. It's the same thing. Same thing I just did, but we're going to multiply each side twice. So pause the video, try it on your own. I'm going to do it now for you. So we have 2x minus 4 divided by 5 is 5. This thing's having a serious problem with the 5s. 3x plus 1 divided by 4. Now, we have two fractions, one on each side. I want to get rid of both the fractions. So to get rid of this fraction, I'll multiply by 5. But what I do to one side of the equation, I have to do to the other. But I want to get rid of the 4 as well. So why don't I just multiply by 4 as well? Like this. That way, these 5s are going to cancel, and these 4s are going to cancel. And what we're left with is 4 times 2x minus 4 is equal to 5 times 3x plus 1. Same thing, we've just gotten rid of the fraction. If you look up here, this could also be thought as, we bring the 4 up here and multiply, and we bring the 5 up here and multiply. Whichever way you prefer to think about it, it's the same thing. All right, let's multiply these. Let's multiply these brackets out. So, oh my God, what's happening? Where am I? There we go. Okay, let's multiply these out. 2 times 4 is going to give us 8x minus 16, because that's 4 times 4. And then 3x times 5 is going to be 15. Oh my God, this thing hates 15, or hates 5s. 15x plus 5. This is terrible. Okay. Again, we're going to bring the 8x over here, and we're going to bring the 5 over here. Boom, like that. So then we're going to have 15, well, yeah, 15x minus 8x. I just wrote the x's on this side for no reason. 15x minus 8x is going to be minus 16 minus 5. So 15 minus 8, that's going to be 7x, is equal to minus 16 minus 5 is going to be minus 21. So x is equal to negative 3, because if we divide both sides by 7, the 7s here will cancel, we'll be left with a 1, and on the right, we're going to have minus 21 divided by 7, which is 3. That's our answer. Now, same as before, here are 3 other questions. Same process that I just did. Go ahead, do them on your own, and hopefully you can get the right answer from what I did. Just same method. You want to isolate the x, we want to get rid of the fraction immediately, then divide by whatever in front of the x to get your final answer. And yeah, that's all there is to linear equations. That's it. Quadratic equations. Absolutely crucial you get good at quadratic equations. You're going to see them in your junior cert. You're going to see them in your leaving cert. With 100% certainty, you need to get good at these. And they're not that bad. So a quadratic is literally just any equation that looks like this. So ax squared plus bx plus c. And a, b, and c can be any number you like. I think students will get confused seeing the a, b, and c. Like an example of this could be like 2x squared plus 4x plus 8. That's a quadratic. Any numbers you like, make them up. Ax squared plus bx plus c. That's how you recognize a quadratic. Now, like it says down here, 2 ways to solve this. Factorization and minus b formula. Minus b formula always works, but when you get good at factorization, it is actually faster. So I'm going to show you. I'm going to solve this with factorization. So we have x squared plus 5x plus 4 is equal to 0. So, first step here is we want to write the factors of the number in front of the x squared, which here is going to be an invisible 1, and the number at the end, which is 4. So the factors of 1 are just 1 times 1. Now the factors of 4 are 2 times 2 and 1 times 4. Now, tricky part. We want to find a combination that will add to 5x here in the middle. So let's try this. 1 times 2 is 2, and 1 times 2 is also 2. Now, if I try to get 5 from the 2 and the 2, there's no way I can get that. I can get 4x, I can get 0x, I could get whatever, minus 4x. We're not going to be able to get a 5x from these two numbers. So let's just get rid of them. Scribble them out, or just like this, put them over here. Now, let's try this. 1 times 1 is 1, and 1 times 4 is 4. Now, if I take positive 1, why does it keep doing this? Positive 1 and positive 4. If I add them, I'm going to get positive 5x. And notice as well, when I multiply these, I'm going to get positive 4. And that's how we know we're right. So, why is this highlighted? I don't know. I'm going to leave it. I'm going to have, so there's a 1x here, and there's another 1x over here. And now I just fill into these brackets. So this 1x is multiplying with the plus 1, so I'm going to put that over here. And then this 1x is multiplying with the 4, so I'm going to put the plus 4 over here. It's important you put the number that's multiplying into a different bracket, if that makes sense. So like this 1 here is multiplying with this positive 1. This is like 1x, you can imagine. There's an x there, but we don't write that. So like this 1x is multiplying with this positive 1. So that's why they're in different brackets. And same here, this 1x is multiplying with the 4, and that's why they're in different brackets. Now, that's equal to 0. What that means, so I'll give you an example. I always say this. I'll write it up here. If I have 4 times x is equal to 0, then what's x equal to? I'm going to give you a second. You could say it or you could just think it. It doesn't matter. X has to be 0. There is no number you can multiply 4 by to get 0 other than 0. So, for this to be 0, either this has to be 0, this has to be 0, or both of them have to be 0. So let's consider this guy's equal to 0. So we have x plus 4 is equal to 0. That means x must be minus 4. And here we have x plus 1 is equal to 0. So that means x must equal minus 1. And that's our answer. If we fill those x values into the original equation, we're going to get we're going to get a 0 with minus 4 and minus 1. And that's all there is to it. That's how you factorize and solve this, or solve this using factorization, I should say. So yeah, try this on your own. Pause the video, give this a go. Same method as I just did, and I'm going to do it now for you if you're stuck. So x squared minus 2x minus 3 is equal to 0. First thing again, factors of 1, 1 times 1. This could be a 2 here, and if there was a 2 here, it would be like a 2 times 1. But all these examples just happen to be x squared. Then the factors of 3 are just 1 and 3. So we're left with only being able to multiply like this, 1 times 3 and a 1 times 1. We need negative 2. So this 3 has to be a minus, and this 1 has to be a plus. Because minus 3 plus 1 is minus 2. And notice when we multiply these, we're going to get the minus 3 we need. So we know we're correct. So here we're going to put a 1x in this bracket, we're going to put a 1x in this bracket, and then we're going to put a positive 1 in here and the negative 3 in here. Perfect. Then, final step, each of these brackets has to be 0. So x plus 1 is equal to 0. Then x must equal negative 1. And x minus 3 is equal to 0. So x must equal 3. Boom. Easy peasy. Same answer, or not same answer, but same method as before. Write out the factors of each of the numbers, sort out how you get the number in the middle, and if they multiply to the number on the right, put them into the brackets, solve the brackets equal to 0 every time. Now, here are 3 examples you can try on your own. I'm not going to solve these for you. Again, like all of these, if you need the solutions, I'm sure you could probably find them online. But yeah, same method as usual. Give these a go in your own time. I'm going to move on. So, oh, my nose. So, the only difference between factorization and the minus b formula, you get the same exact answer in either case, but minus b formula will never be wrong. Like you're always going to get the correct answer with the minus b formula. Whereas with factorization, you might not be able to find a combination that will like add to the number in the middle, let's say. So if you're ever stuck, you can always fall back on the minus b formula. So I'll try this one. So we have 2x squared minus 4x minus 6. So yeah, a is going to be the 2 here. B is minus 4. Be careful of the sign. And C is minus 6. So x must be minus negative 4 plus or minus the square root of minus 4 squared. Hello. Minus 4. Why does this happen? Minus 4 times 2 times minus 6, 4ac, divided by 2 times 2. Now, what's that going to be? Minus times a minus is a plus, so we're going to have plus 4, plus or minus. Square root of 4 times 4 is 16. Minus, well, we have minus 4 times a minus 6, so that's going to be a plus. And 2 times 4 is 8. 8 times 6 is 48. So we're going to have 56 plus 48 divided by 4. Because 2 times 2 is 4. Now, next line. We're going to have a 4 plus or minus the square root of 56 plus 48. That is 64 divided by 8. Divided by 4, sorry, not 8. And then the square root of 64 is 8. So we're going to have 4 plus or minus 8 over 4. And that's equal to 1 plus or minus 2. So over here, we have our x values. Our x is equal to 1 plus 2 is 3. Or x minus, or x is equal to 1 minus 2, which is minus 1. Boom. Those are the x values. And again, if you plug these into the original equation, you should get 0. And that's all there is to the minus b formula. If I were to do this via factorization, I'd probably get the same number. So yeah, try this on your own. You can try it using factorization or using the minus b formula, whichever one you prefer. Because we're doing the minus b formula, I'll do this again. So we have a is equal to 6, b is equal to minus 10, and c is equal to minus 4. Now, x is equal to minus b, which is just going to be 10 because 10 is minus 10, or b is minus 10, plus or minus square root of minus 10 squared minus 4 times minus 4 times 6, all divided by 2 times 6. B squared minus 4ac divided by 2a. That's equal to 10 plus or minus the square root of 100, because minus 10 squared is just going to be 100. Minus 4 times minus 4 is going to be 16. 16 times 6 is going to be 96, so it's going to be plus 96 divided by 2 times 6 is 12. So that's going to be 10 plus or minus the square root of 196 is 14, is it? 196. 14, yep. Plus or minus 14, all divided by 12. So that means x is either, so 10 plus 14 is going to be 24 over 12, which is 2. Or x is going to be 10 minus 14 is going to be minus 4 over 12, and that's going to equal negative 1 over 3. Boom. So those are your answers. X is 2 and x is equal to negative 1 over 3. Now, again, as always, here are 3 more examples. Try them using factorization. Try them using the minus b, whichever one you prefer, whichever one ends up giving you the right answer. And that's all there is to quadratic factorization. Or not factorization, solving quadratics using factorization and the minus b formula. But yeah, know these inside out. They're going to come up on your leaving cert. They're going to come up on your junior cert. You have to know these. There's no ifs, ands, or buts about it. You need these. One last thing to do with quadratics. You may be asked a question like this, where you have to find the roots, or find the quadratic given the roots. In every other example, we had to find the roots given the quadratic. So right now, we have x equals 2 and x equals negative 1. Well, if you remember from how we were solving the other equations, that would mean that x times minus 2 times x plus 1 would equal 0. Because in the other steps, this is how we used to get to these values. We would have these brackets multiplying equal to 0. So we're just bringing the numbers over to the other side and we're multiplying them together. Now let's just expand these brackets. The way we do this, split and repeat. Split this bracket, repeat this bracket. So split this guy, x times x plus 1, repeat him, and then split him again, minus 2 times x plus 1, repeat. X times x, x squared. X times 1 is just x. Minus 2 times x is minus 2x. And minus 2 times 1 is minus 2. Simplify this, we're going to have that's equal to 0. Well, actually, no. We're just trying to find the quadratic. It's fine. So x minus 2 is going to be minus x, and then we just have the minus 2. There we go. That's the quadratic. Or you could say 1x squared minus 1x minus 2. Same thing. That's how you get the quadratic. What I just did there is what we normally do, just in reverse. And you get the same answer. And again, here are 3 examples if you want to try give these a go. I'll give you a hint for this one in particular. Question 3 here. If we have x is equal to 2 over 3, that means that 3x is equal to 2. And if we have x is equal to negative 5 over 7, that means 7x is equal to negative 5 because we multiply each bracket or each x by what's on the bottom of the fraction. So then we can have 3x minus 2 here and 7x plus 5 here. And then you multiply these out. Students get confused with this because normally they just bring over the fraction and then multiply that, and it gets really confusing because you're doing fraction multiplication. Just do it like that and you should get the right answer. And now that's all there is to quadratics. That's it. Last thing, factorization or factorizing. What is it? It involves simplifying expressions with multiplying terms or with multiple terms. The way I put it, you're just making difficult equations look easy. You're just making them look nicer. The methods, this should be highest common factor, not just common factor. So yeah, we have highest common factor, we have difference of two squares and quadratics. Highest common factor we could also use as grouping, like this. Grouping is highest common factor when there's like four terms, but they're the same thing, so they kind of fall under the same umbrella. So this, we're going to use highest common factor to simplify this expression. So we have 6x plus 4y minus 16. Off the bat, yeah, this has an x, this has a y, and this has no letter. So there's going to be no letter in common with any of them. Now we're looking for the highest common factor between these. So highest common factor, the factors of 6 are 1, 2, 3, and 6. Factors of 4 are 1, 2, and 4. Factors of 16 are 1, 2, 4, 8, and 16. Keyword highest. Highest common factor between these guys. Well, we have a 2 here, a 2 here, and a 2 here. We have a 4 in each of these guys, but not this guy. So I think 2 is the highest common factor between them because they all have the 2. So now we're going to take the 2 out and put the rest in brackets. How do you get what goes in the bracket? Well, we just divide each of these by the 2. So 6x divided by 2 is going to be 3x. 4y divided by 2 is going to be a 2y. And then the minus 16 divided by 2 is going to be a minus 8. That's it. That's that thing simplified using highest common factor. That was a very simple example, though. We'll do another. This guy, give this a go without me doing it. Pause the video if you want. Give it a go. I'm going to do it now, so hopefully you've tried it. So, we have 4x squared plus 8x. Now here, sorry, my nose is so itchy. God damn. All right. No, not all right. My nose is crazy itchy. All right. 4x squared plus 8x. Let's write out the factors of the 4. We have 1 and 4, and 1, 4, and 2. Sorry. Yeah. 1, 2, and 4, I should say. 1, 2, and 4. Factors of 8 are 1, 2, 4, and 8. So off the bat, we can see the highest common factor between them is 4. 2 is a common factor between them as well, but 4 is the highest common factor. So we're going to use the 4. Also, note, they have an x in common because here we have x squared. That's just equal to x times x. So they also have an x in common. So we're going to take the 4x out. And again, what goes in the bracket is you divide these by the number outside. So 4x squared divided by 4x, we're going to be left with an x. And then 8x divided by 4x, we're going to be left with a 2. Boom. That's it. Factorized using highest common factor. Now, will you have some examples? Common factor. I'm going to let you do this on your own. Even though there's an extra term, same thing. Look for what number they have in common and any letters they might have in common and write it out as simply as you can. And I think, yeah, you'll have more examples here. Give these a go on your own. Hopefully you get them right. It's the same thing every time. Look for the common number, look for the common letter, put it on the outside, everything else on the inside. Also, if you want to check that you're right, you can just multiply these brackets out to make sure. So like 4x times x is going to be 4x squared, and then 4x times 2 is going to be 8x. So that's how you know you're right. You can just check on your own. Next thing, difference of two squares. This is arguably one of the trickier ones of difference or of factorization. This formula here, you just have to learn it. You just have to memorize it. As much as I hate saying that, I hate when you just have to learn something like, but this equation here, you just have to know it. There's no way you could ever come up with this in an exam. And to prove it, you can just multiply this bracket out and you'll get this. But I'll do an example. So we have x squared minus 25. Minus 25. Boom. What we can write this as is x squared minus 5 squared. I'll do it like this. Boom. 5 squared. Now, I always say to students, you should know very well the square numbers. So 1, 4, 9, 16, 25, 36, 49, dot, dot, dot. You should know the square numbers very well. You should be able to recognize that 8 squared is 64. And if you see like a 64, you go, oh, that's 8 squared. Or if you see 121, you recognize that's 11 squared. So basically, these numbers now, we have two numbers squared with a minus sign. So we have the minus sign is the difference. We have the two numbers and they're both squared. Difference of two squares. So we can use difference of two squares. So now we just put x minus 5 times x plus 5. That's it. Done. That's the answer. And if you multiply these brackets out, you should get this thing at the front, or at the top. And that's basically all difference of two squares is every time. Give this a go on your own, quickly. I'm going to do it now for you. And hopefully you've tried it on your own. So we can rewrite this as 3x all squared minus 10 squared. Again, we have two numbers, we have the difference, and they're both squared. So we can go 3x minus 10 times 3x plus 10. Boom. Easy peasy. Every time, same thing. It's just that initial formula here. That's what students forget. And you need to learn that. That's one thing you have to learn off by heart for your exams. And I think now, yeah, here's some examples for you to try. And they're the same thing over and over again. So hopefully you get the pattern here. And you can check them again if you multiply out the brackets. Now, final piece of factorization I'm going to do today, quadratics. And I just showed you how to solve quadratics. So this is literally the same thing as what we did before, but we're just not solving for x. X squared plus 6x plus 8. What am I going to do? I'm going to write the factors of the 1, or of the term in front of x. It's a shame that all of these have been 1, because it could be a 2, and then it's a bit tricky, but I hope you've seen that before, probably in school or something. 8 here is going to be 1 times 8 and 2 times 4. Now, we want a combination that will add to 6. I can already see this 1 and 8 isn't going to cut it. I'm going to put them away. 1 times 2 is 2. 1 times 4 is 4. If I take the positive of both of these, 2 plus 4 is going to give us 6, and 2 multiplied by 4 is going to be 8. So we're going to have x plus 2, x plus 4. That's it. We're not putting it equal to 0. We're not solving for x. Here it's saying factorize. If this here said solve, then we would start doing the equals to 0 and getting the x values. This just says factorize. So don't do more than you're told. Just do the factorization and move on. Okay, and again, here's some more examples. This one thankfully has a 2 in it, so that one will be a bit tricky. But yeah, that's all there is to factorization as well. And that kind of concludes my algebra summation today. So hopefully you enjoyed, you learned something. So we did what? Factorization, quadratics, and linear equations. 3 really good things to learn for your exams, Junior Cert and Leaving Cert. This is how we teach a breakthrough maths. Hopefully you enjoyed. If you did, sign up for some classes, learn some maths. We're always open to new people. And yeah, thanks for watching. Go on, have fun.